Hi, I'm again with new video. So in many cases people face this problem and they don't know like what to do. So this is very important for your research, especially when you are trying to publish your result or research. Then you have to give your clean NMR. So you synthesize your compound, you made your compound, and then you have to take your carbon NMR and proton NMR. But the problem is, in many cases, your carbon NMR and proton NMR will have residual solvent peak. Like suppose you did the extraction or anything with ethyl acetate. So at the end, even if the product is very pure after doing column or recrystallization, but it's still you might see the ethyl acetate peak in your proton NMR or carbon NMR. And also if you deal the compound with DCM, dichloromethane, or like do the purification, recrystallization or column with the dichloromethane, or somehow it gets some amount of the dichloromethane, you'll see a residual peak of dichloromethane at 5.31, and for ethyl acetate you will clearly see a quartet around 4.10, and also there are some other peak like lower value like around 1.1 or something. So if you use any other solvent like acetone, if somehow when you wash your flask or container to take your pure product and you wash with the acetone, and residual acetone could be there, and the acetone peak can be like 2.1, around 2.1. And if you have acetonetyl, that will show the residual peak 2.2 or something. So there is a paper, I'll show you the paper link. You can find the residual peak of the solvent in different deuterated solvent you are taking your NMR. Like in CDCl3, what are the solvent peak in that CDCl3 of those solvent? Like water, always you will see like 1.56 in the peak at CDCl3. Whatever the peak already I have mentioned here, all are based on like the CDCl3. So there are many other solvent you might see the residual peak in the proton NMR or carbon NMR. But how to remove those? Like how you can remove completely? Even if your product is very pure, still you might see those residual peak in the compound NMR. So what is the solution? Solution is I would take a certain amount of the compound, pure compound, like even like after column or recrystallization, even if it is crystal. Then remember that if it is solid or crystal, so always there will be some solvent trapped inside the solid crystal, like a solid. Even if it is gummy material, still it like solvent can be trapped in the gummy materials. So in that case, just take your sample, whatever amount you want to use to do the proton NMR or carbon NMR. So remember one thing, depends on the molecular weight. If it is like below 500 molecular weight, so for the proton NMR, 2 milligram, 3 milligram is enough for the proton. Or if you take 4 or 5 milligram, it's still fine. But if you take too much concentrated amount for the proton, so it will show the shimming problem and your peak splitting will not be visible nicely. So it is better to take the proton NMR for a small amount, like diluted condition, but not less than 2 milligram. But if your compound molecular weight is like above 1000, so I would say for the proton NMR use 5 to 10 milligram. So use your knowledge, like how much you are increasing. But for if the molecular weight is like below 500, then for the carbon NMR use at least 20 to 25 milligram of the sample, then you will get nice carbon. But if you have the molecular weight more than that, like 1000 or like 1500, so in that case you might need to increase the amount, like 50 milligram to 60 milligram. But in many cases people make the compound after 9 or 10 step synthesis, and finally they come up with like 10 milligram or 15 milligram of the final pure product. In that case, if you want to take the proton NMR, you can use 5 milligram, it's fine. But for the carbon NMR, you can run like overnight or like 24-hour scanning, so increase the scan number or transient number, so you can get the nice signal for the carbon NMR. But that is very like not recommended. If you have good amount product in your hand, just use more concentrated. Now the point is how to remove those residual residual solvent peaks from your proton or carbon NMR. So as I was saying, like the solvent, those residual solvent or like trace amount of other solvent can be trapped inside the solid or like the gummy liquid or in the compound. So what I do, I take my required amount of the sample and I add the deuterated solvent what I'm going to use for the final proton NMR or carbon NMR, like suppose CDCl3. So I take 5 milligram of my sample, add some CDCl3, dissolve completely, then I do the rotobap, and then I dry with the vacuum pump. So in that case, in the CDCl3 solvent, it dissolved and ultimately trapped solvent from the solid structure came out, and that can go with that CDCl3. And then finally, once it is dried under vacuum for a long time, or like if you have the strong vacuum, like maybe half an hour, and then you can add your again you can add final CDCl3 for the NMR purpose. Just add the CDCl3, take the NMR, and definitely you will see there is no residual solvent peak in your proton or carbon NMR. So in some cases, although it is not recommended, in some cases it is really tough to remove all the solvents like residual peak. And if you know your compound is like heat stable, like temperature is stable or like heat is stable, you can heat it up. So in that case, what I do, I do the same thing. I take 5 to 10 milligram of the sample and add the CDCl3. If I am planning to take the NMR in CDCl3, add the CDCl3, and then I take in a vial and I just use the vial with a hot water bath to evaporate all the CDCl3 from that vials. And once it is all solvent is gone, and then still I try to do like to make it all those solid or like dried out, and then I use vacuum pump for like depends on the strength of the vacuum pump. Like if it is high vacuum pump, then I use 30 minutes. And if after 30 minutes I take this vial again in the hot water bath, make it hot, and immediately I use again in the vacuum pump and keep it 30 minutes again, and then I'll take the final proton and carbon NMR for the publication purpose. So I hope this video will help you to remove your residual solvent peak from the proton and carbon NMR. And if you like my video, please subscribe my channel and share it to your fellow researcher, who is especially the people who are just starting research in the lab, or like your student or your colleagues, so it will help them also. And thank you who already have subscribed my channel and who are supporting my channel. Thank you.